In this video, we will talk about properties of matter. So first we'll define what matter is. Matter is anything that has mass and volume. When we talk about mass, this is the quantity of matter in a substance or object. Mass can be measured in milligrams, grams, or kilograms. And note these are all standard international units. Volume is the amount of space that a substance or object occupies, and volume is measured in milliliters or liters. Now, all matter has volume, even if the volume is very, very small. Matter exists in three forms or three states. It can exist as a solid, liquid, or gas. And matter can change from one state to another. So matter can go from a solid to a liquid, or a liquid to a solid, or a liquid to a gas, or a gas to a liquid, or a solid, to a gas. So these changes, these phase changes, all have different names. So if we're starting with a solid and we are going to a gas, this is referred to as sublimation. If we have a solid and we are going to a liquid, this is referred to as melting, and then a liquid to a solid is known as freezing. And then if you have a liquid going to a gas, this is evaporation, and a gas going to a liquid is called condensation. So matter can go between any of three of these states, and each change of state has its own name. So with these different states of matter, what are the different properties associated with them? So with the properties of each state of matter, we'll start with the solid. And with the solid, we have small spaces between the particles. And so we will define the properties based on shape and volume. Now the shape of a solid is definite, meaning like the shape can be defined. And the volume can be defined as well. So it has a definite volume and a definite shape. Now a liquid, where there's some space between the particles, has an indefinite shape. So a liquid will take the shape of whatever container it is in. So that shape will always change, whereas the volume is definite, or it is defined. So whatever volume of liquid you have, that volume will stay the same no matter the size of the container. With gas, where you have a large space between the particles, the shape is indefinite, meaning those gas particles will take the shape of the container. And the volume is also indefinite. So the volume of a gas is based on the size of a container. So whatever container the gas is in, it will take on the volume of that container. Now, to help explain these different properties of matter, we can use what is called the particle theory. The particle theory has 5 different points to it, all of which can be used to explain the behavior of matter. So in particle theory, the first point is that all matter is made up of tiny particles. Second point is that all particles in the same type of matter are identical. So each substance has its own kind of particle. So if you have salt, for example, the particles in that salt will all be identical, versus the particles in sugar, which will be identical but different from that of salt. Now, in the third point, there is an attractive force between these particles. So as these particles get closer together, the attractive force between the particles is stronger, so it holds them kind of closer together, or they have a stronger attraction. The further apart the particles, the weaker the attractive force, or the weaker the attraction between the particles. So as they move further and further apart, there's less attraction between the particles. Now, there are spaces in between the particles, and so, for example, solids have small spaces between the particles, while gases have very large spaces between them. And the particles are in constant motion. Particles at a higher temperature will move faster, particles at a lower temperature will move slower. And even particles in a solid are moving as well. They're just kind of vibrating in place, which is still movement. And so this diagram here just shows these different ideas of particle theory that we just talked about. So in a solid, the particles are very close together. You can see there's individual particles here, and they're almost touching each other. You can't see it in the picture, but they are moving. They are vibrating in place, and that's those particles moving. Now, because these particles are very close together, they have a strong attraction to each other, and the space between them is very small. You can see very small space. In a liquid, the space between the particles is further apart, so there is more distance between the particles. As a result, the attraction between the particles is weaker. And then in a gas, the space between the particles is very, very large. So you get very large space between these two particles. And as a result, the attraction between these two particles is very, very weak. And the particles in a gas are moving freely. Now, based on particle theory of matter, matter can be classified either as a pure substance or mixture, depending on how the particles are arranged. Different types and combinations of particles give every type of matter particular characteristics or properties. So the particle theory part, in the particle theory, the SAM part, the spaces, attraction, and motion part, can actually be used to explain the properties of solids, liquids, and gases. So as we talked about, the spaces, in a solid, there's very little space between the particles. And because there's very little space between the particles in a solid, there is strong attraction between the particles. And because there is a very strong attraction, there is very little motion in the particles of a solid. In a liquid, the space between the particles, there is some space between those particles, and as a result, there is some attraction between the particles. The attraction is less than that of a solid, but as a result, the particles have a lot of motion. In a gas, there is lots of space between the particles, and there is very little attraction between the particles. And as a result, the particles are moving freely about. So the SAM part, the spaces, attraction, and motion part, can also describe what happens to particles as changes of phases occur. So we can use the SAM to describe what happens as liquid water becomes gas. So we can write this one out here. So if we have our liquid water, and then remember, if we have our particles here, particles are going to be relatively kind of close together, but they are going to be kind of, moving about. And we're talking about liquid water becoming a gas. And in this case, when liquid water becomes a gas, this is where it becomes steam or mist or, a vapor, things like that. So here, the particles now, are going to be kind of further apart here. So we'll use the SAM to describe what is happening to these particles as liquid water goes to a gas. And so we have the spaces part. So as liquid water goes to a gas, the spaces, or the space between the particles will increases. So the distance between these particles has gotten larger. The particles themselves do not get larger, the spaces between the particles get larger. For the attraction part of particle theory, as liquid water goes to a gas, the attraction between the particles decreases. And for the last part, the motion, as liquid water goes to a gas, the motion of each particle, or the motion of the particles, will increase, or we'll say increases. And so this is the SAM part, using to describe what happens to that phase change. And we can include the first part, the all matter is made up of particles. We could include that in our statement. And even the I part, that liquid water or water is made up of identical particles, or all the particles in water are identical. So on your own, you can use the SAM part to describe what happens as liquid water becomes ice. So follow that same process that we did, describe what happens to the spaces, the attraction between the particles, and the motion of the particles as liquid water becomes ice. So basically liquid, to solid. And that is the end of this video for properties of matter.